You know, from the alarm clock that wakes you up, to the coffee maker that starts your day, to the car that gets you to work, our entire world is running on a massive, invisible army of tiny computers. So today, we're going to pull back the curtain. We're going to find them, figure out how they work, and uncover the secret network that connects them all.
So let me ask you a quick question. What could a washing machine, a car, and a modern smartwatch possibly have in common? I mean, they seem like they're from totally different worlds, right? But here's the thing. They all share a powerful secret. A tiny, hidden computer brain that's designed to do just one job, and do it perfectly.
All right, so here's our game plan. We're going to start by finding these invisible computers that are hiding in plain sight. Then we'll see how these little systems scale up to run our entire world. After that, we'll dive into the Internet of Everything and figure out how all these smart devices actually talk to each other. But then we have to talk about the hidden weaknesses, because there are some big ones. And finally, we'll look at how we can secure our smart future. Okay, so that secret I mentioned, that hidden brain inside all those different devices, well, it has a name. It's called an embedded system. And trust me, once you know what you're looking for, you are going to start seeing them absolutely everywhere. Think of it like this, right? Your laptop or your phone, that's a generalist. It can browse the web, play games, do spreadsheets, thousands of different things. An embedded system, on the other hand, is a specialist. It has one single job, and it's designed to do that one job flawlessly, usually without you ever even knowing it's there. It's the little computer in your microwave that's just dedicated to running the defrost cycle, or the critical chip in your car's brakes that stops you from skidding. And, I mean, they are literally everywhere. Your smart thermostat, the fancy infotainment system in your car, even critical medical devices like health monitors. Heck, even the office printer you fight with every day. They all rely on these dedicated little computers to get their jobs done. But here's where it gets really interesting. These systems do way more than just manage our personal gadgets. These scale up, way up, to run the very foundations of our society. So on one end of the spectrum, you've got these awesome hobbyist-friendly platforms like the Raspberry Pi or Arduino that let basically anyone build their own smart devices. But then, on the other end, you have things called FPGAs. You can think of these as like super-powered shape-shifting chips that can be completely rewired on the fly for incredibly demanding jobs, like managing a whole cell tower. And this is the key takeaway, right? It's not just about cool DIY projects. The very same principles that power a little homemade robot are the same ones that get scaled up to manage the infrastructure that we all depend on every single day. These industrial scale systems are often called SCADA or ICS. And let me tell you, these are the true silent operators of our modern world. These are the embedded systems that make sure our lights stay on, that our water is clean, and that our factories keep running. They are our critical infrastructure, and when they fail, the consequences can be, well, pretty catastrophic. Okay, so we've got billions of these specialized little computers all over the place. Now, what happens when you give all of them a way to talk to each other and to us? Well, you get something you've definitely heard of, the Internet of Things. The IoT is basically the digital nervous system that connects all of these devices. It's the magic that lets a simple sensor on a bridge talk to a powerful server in the cloud, transforming millions of standalone things into one giant, intelligent web. And its impact is just massive. In a factory, it's not just a robot arm anymore. It's a robot arm that can actually feel when its own motor is wearing down and then automatically schedule a repair before it breaks. At home, your fitness tracker is your own personal IoT device, collecting data to help you stay healthy. This connectivity, it's changing everything. So, for billions of devices to connect without it being total chaos, they need to speak the right languages. Or, in the tech world, they need to use the right communication protocols. And it's definitely not a one-size-fits-all situation. An autonomous car needs the lightning-fast, almost instantaneous speed of 5G to make split-second decisions. But your smart lights at home? They just need a simple, low-powered network like Zigbee to talk to each other. And what about a water meter way out in a remote field? It needs something like narrowband so we can just sip power and send tiny updates for years on a single battery. All right, so far, this all sounds pretty amazing, doesn't it? A world of smart, connected devices making our lives better. But, and this is a big but, this hyper-connected world has a pretty serious dark side. With every new connection comes a new potential door for someone to break in.
The single biggest problem is almost laughably simple if it wasn't so incredibly dangerous. Imagine you buy a brand new house. You move in, and you find out the builder just left the front door wide open with a welcome mat that says, "Hey, the key's under here." That's basically what we're dealing with.
It's wild, but so many devices ship with default usernames and passwords like admin and password that nobody ever changes. Often, the data they're sending back and forth isn't even encrypted. And worst of all, many of these things are designed without any way to receive security updates. So once a flaw is found, it's there forever. This isn't just a theory. These exact flaws are what allowed the infamous Mirai botnet to turn hundreds of thousands of webcams into a giant cyber weapon that took down huge parts of the internet.
So you're probably asking, why does this keep happening? Well, it's a constant tug of war between security, cost, and power. To keep a device super cheap and make its battery last for months, you have to use a less powerful chip. But that same weak chip struggles with heavy-duty encryption. So, to hit those price and power targets, security is often the first thing that gets left on the cutting room floor.
And all of this creates this really dangerous mindset we call implied trust. We just assume a simple smart light bulb is harmless. I mean, what could it possibly do? But to a hacker, that's not a light bulb. That is an unguarded side door into your entire home network.
Okay, the situation sounds pretty serious, and it is. But it is far from hopeless. We actually have the tools and the knowledge to fix this. So let's look at how we can build a more resilient and secure smart future. As users, we actually have way more power than we think. And the basics? They're completely non-negotiable. The very first thing you do with any new device is change that default password. Always, always enable automatic updates. And if you want to go a step further, isolating your smart devices on their own separate Wi-Fi network is like building a digital firewall around the rest of your home.
But really, while we can put up firewalls, it's the manufacturers who have to build stronger houses in the first place. The real responsibility lies with them. The core principle has to be security by design, baking security in from the very first blueprint, not trying to bolt it on as an afterthought. And that means planning from day one how you're going to deliver security patches for the vulnerabilities that will inevitably be found down the road.
So as we wrap this up, it's pretty clear, right? These invisible systems are, without a doubt, the bedrock of our modern society. They bring incredible convenience and efficiency and new capabilities to every single part of our lives, from how we manage our homes to how we run our most critical industries. But all of this convenience, it comes with an immense responsibility. So the real question we have to ask ourselves is this: as we build our future on this invisible foundation of smart devices, are we building it on solid rock or are we building it on sand? Something to think about. Thanks for joining me.